Hi, this is Mr. Singh here, and today's lesson is going to be on background radiation, which is part of the AQA physics syllabus. Before we start on background radiation, quick retrieval practice. There are 7 questions here. Pause the video and have a go at these, please. Okay, let's have a look how you got on. Number 1, which part of the atom is radiation emitted from? That will be the nucleus of an unstable atom. Number 2, what are the 3 types of radiation? That will be alpha, beta, and gamma. Number 3, can temperature affect the amount of radiation emitted? No. Radiation is a spontaneous process. Temperature cannot affect it. Number 4, which type of radiation causes the most internal ionization? Well, that would be alpha. Number 5, which type has the longest range? That would be gamma. Number 6, which type of radiation can be used to treat cancer? Gamma radiation. Obviously, when cancer treatment is taking place, they take special care in making sure healthy cells are not exposed to gamma radiation. It's just purely cancer cells that are exposed. And not only that, but the dose and the frequency of gamma treatment, it is crucial. Number 7, what's the difference between contamination and irradiation? If you get radioactive source mixed with your food, or if you touch it, then you or your food is now contaminated. If you're exposed to radiation, then that is irradiation. Okay, so let's move on. So you can see the 3 objectives. That's what we're going to do today. Keywords: radiation, source, sieverts, and half-life. So I want you to pause this video and have a think about this. And where is radiation found? Jot down as many places, whatever you think. Okay, what we're going to do is, through the course of this video, hopefully you'll be able to answer this question: where is radiation found? So if we move on, why is radiation important? See if you can answer this question. Okay, well, let's have a look. Because radiation can harm your body, so it's therefore important to be aware of radiation dose. We need to understand radiation. What is radiation dose? Again, pause the video. Well, this is a measure of the risk of harm to your body due to the exposure to radiation. What affects radiation dose? The type of radiation, the amount of radiation your body is exposed to, and then what are the risks. See if you can write some risks down. Okay, if we then move on, let's have a look. The greater the radiation dose, the greater the chance of developing cancer. How is radiation dose measured? The radiation dose measured is in sieverts. Now then, background radiation. All the time we are exposed to low-level background radiation. Clinically, it's not harmful, but there is background radiation all around us. But where exactly from? Well, space, rocks, food, medical use like say X-rays, and nuclear power stations, nuclear waste, nuclear weapons fallout. This pie chart shows you a quick picture of background radiation and where from. So let's look at the occupations, more at-risk occupations: nuclear power industry, radiographers in hospitals, and miners as close to that work close to rocks. So how do we protect? How do these people protect themselves? Well, lead aprons, lead screens, monitoring badges, protective clothing, masks, and recording the amount of time they've been exposed. Does where you live have an effect? If there is a lot of granite rock, then this can cause higher levels of radiation. Radon gas can be released by rocks. High altitudes, where they are more exposed to cosmic rays, that's from space. What are the dangers in space? Pause the video here and jot down what you think the dangers are in space. Okay, well, let's have a look. The first hazard of the human mission to Mars is the most difficult to visualize because, well, space radiation is invisible. Radiation is not only stealthy, but considered one of the most menacing of hazards. Above the Earth's natural protection, radiation exposure increases cancer risk, damages the central nervous system, can alter cognitive functions, reduce motor function, and prompt behavioural changes. Now, to learn what can happen above low Earth orbit, NASA studies how radiation affects biological samples using a ground-based research lab. The space station, which sits just within the Earth's protective magnetic field, so while our astronauts are exposed to 10 times higher radiation than on Earth, is still a smaller dose than what deep space has in store. To mitigate this hazard, deep space vehicles will have a significant protective shielding. Research is also being conducted in the field of medical countermeasures, such as pharmaceuticals, to help defend against radiation. And that concludes our lesson on background radiation.